All right, moving on to the third page here. Starting with number 17. These ones are good problems because you just have to set up a picture, and then it's basically the same as the whole last page. All right, so it says find the measure of angle Q in an acute triangle. So our best bet is to first start with a triangle. Doesn't really matter. And PQR. So I'm just going to label it PQR. Okay, and then it says given that the measure of angle P is 48, so I'm going to fill in 48 degrees here. PR is 62, so that's this side right here. And QR is 50, so that's this side. They want us to find angle Q, so I'm just going to call that X so I know. And so now I have to decide. I don't have a right triangle, so I can't use SOHCAHTOA, so I have to use law of sines or law of cosines. Well, this one, they have the angle on its opposite side, and I'm trying to find that angle on its opposite side. So I'm going to use law of sines. Sine of 48 over its opposite side, 50, equals sine of x over its opposite side, 62. Cross multiply. I get 62 times the sine of 48 equals 50 times the sine of x. And notice I'm trying to solve for an angle, so I want to get that alone. So I'm going to go ahead and divide both sides by 50. Okay, so I'm going to go to my calculator and type that in. 62 times sine of 48, and then divide it by 50. And I get a decimal point 0.9215. So I'm going to go up here. 0.9215 equals sine of x. Last step is to inverse. So when I go to my calculator and inverse that, my angle is going to equal, come on, sorry, inverse, and I get 67 degrees, 67.1 we'll say. So my angle is, sorry about the small work, I should have separated those out. All right, so this number 18 is basically the same. I'm going to set up in a triangle, and it looks like it's called DEF now. And the measure of angle F is 54 degrees. Little e is 70. Well, little e is the side that's across from angle E, so that's 70. And little d, which means the side across from D, is 50. Notice I have side, angle, side, so I'm going to be using law of cosines. So I'm going to set that up. I got a lot more room down here now. So I have x squared, because I don't know what that is, equals 70 squared plus 50 squared minus 2 times 70 times 50 times the cosine of my angle, which is 54. And I'm going to type that all in my calculator. 70 squared plus 50 squared minus 2 times 70 times 50 times the cosine of 54. So x squared equals 3,285.5. So I go back and I square root it. Oopsie, somehow I got a parenthesis in there. Okay, 57.3, so, oops, not degrees, making some silly errors. It's, what do we have? Is there any measurements given? Centimeters. Now always go back up, guys, and check to make sure it makes sense. If the other sides are 70 and 50, it probably makes sense that that one's 57.3. Okay? Right, a few more word problems. Angle of depression for this one, angle of elevation, those keywords we learned. The first one, the angle of depression from the top of a 320-foot office building. So I'm going to stop there. And your first note to self should be, all right, I might as well just draw a building that's 320 feet. Okay? Okay, and it says the angle of depression. So remember, for the angle of depression, I need to draw a horizon to the top of a 100-foot office building. So somewhere over here, we have an office building that's 100 feet. And the angle going to the top of it is 55. So that's the angle of depression. They want to know how far apart are the two buildings. So they really want us to find this distance right here. Well, we can find this distance by taking the 320. Let's use a different color. Taking the 320 and subtracting this 100. That leaves me with a height of 220. So this distance right here is 220. Well, this is a right triangle, and I know the opposite and the adjacent is what I'm trying to find. So I'm going to use tan. So I'm going to jump down here, and I'll erase it when we get to the next problem. Tan of my angle equals my opposite side, which is 220, over my adjacent, which is x. And since I know the angle, I'm going to cross multiply. X times the tan of 55 equals 220, and this is just a number, so I'm going to divide by it. That's now gone. I'm left with x equals 154. We'll just leave it at 154. 154 feet apart, those buildings are. Okay, so I'm just going to leave that up. Just note that goes to that top one. Okay, the next one, Kale is flying a kite with 400 meters of string out. So my first step would be draw Kale and a kite. And we know that the kite string is 400 meters. He is holding the kite 2 meters above the ground, which means his hand right here to here, that's 2 meters. And the angle of elevation of the kite, excuse me, is 55 degrees. So I have to draw in my horizon line. That's 55 degrees. Right, so what we need to find is how high the kite is. Well, we already know it's got a base starting at 2 because that's how high his hand is. We need to find this value right here, and it's a right triangle, so I can use trig. Opposite and hypotenuse are the two sides I'm dealing with here. So I'm using sine. So sine of 55 equals x over 400 over 1. I can cross multiply, and this one's nice. I get x equals 400 times the sine of 55. And 327.6 is how high the kite is from his hand up. 27.6, I think it was. We'll round up to 7. That's how high the kite is from his hand up, so we need to add the 2 meters. So in total, the kite is 300 and, oops, I messed up on my number, 327.6. So in total, the kite is 329.7 meters if I add in those 2 meters. All right, a few more problems left on this page. I think we have 3 left. This one is a nice problem because it's a word problem, or not really a word problem, but it's an application going back to circles chapter. And what you have to notice on this one is that this angle right here is inscribed in an arc that's half a circle or a semicircle, which is 180 degrees. So that must mean that this is 90 degrees. And that's the important part because now I can use right triangle trig. So I want to find the radius. I'm going to have to find the diameter first. So we'll call that D. Man, I'm getting sloppy. All right, DE. So I have opposite and the hypotenuse. So I'm going to use sine of 37 equals 41 over D. Cross multiply. D times sine of 37 equals 41. Divide by sine of 37 because that's just a number. I'm left with diameter equals 68.1. And so I'm going to divide that by 2 to get the radius. So the radius is going to equal 34 approximately. Okay, so that's a good problem because it goes back to circles. And these two are also good problems because they involve multi-step problems. We did a whole worksheet on this. Okay, so what I want you to look at in this first one is first we know that QT is 50. And I want you to just look at this one triangle. They want us to find RS. Well, it makes sense to first find QS and then to find RT and then just subtract them. So I'm going to use trig to find this value right there. And I need to use tangent because this is the opposite and this is the adjacent side. So tan of 40 equals 50 over x. When I cross multiply, when I divide, I get that value to be 59.5. So this value right here is 59.5. Now I want you to look at this big triangle. And I want you to find this whole length. So from here to here, we'll call that y. Still using tan. So I'm going to set up tan of 30 equals 50 over y. And same cross multiplication. And you can go through that extra work. You have to do 50 divided by tan of 30. Oops, not tan of 3. Uh-oh, I did 550. 50 divided by tan of 30. All right, let's see if I can get this. 86.6. So that means this value up here is 86.6. So to find what's left over, I'm going to go back up here. To find this part right here, I'm just going to do 86.6, subtract 59 point, we can round that up to 6. Okay, and in the end, that's going to give me RS to equal. Oh, if I had a brain, I could do that right now. 59.6, I should do this in my 27. So that is 27, and let's see if they gave us a label at all. Centimeters. There are multiple ways to do that one, but I find that to be the easiest one, most logical. You only have to find two values and then subtract them. All right, so let's look over this next one. This one's just like all the multi-step ones you've been doing. Okay, so let's just start with looking at this triangle. I should be able to find x using that because this is the opposite and this is the hypotenuse. So I have sine of 70 equals x over 12.4. Cross multiply, x is going to equal. Let's go ahead and write that. Okay, so I get 11.65. Now I need to use that to find y, so I'm going to be looking at this other triangle now. This is still the opposite, and this is the hypotenuse, so I'm still going to be using sine. So I have sine of 48 now equals 11.65 over y. Cross multiply. Y times the sine of 48 equals 11.65, so I'm going to divide. Let's see what y gets us. 1.65 divided by sine of 48. Come on. 15.68. So notice it's a multi-step because I had to use my original value of x to find y. All right, and I think that wraps up page 3, so we'll move on to the final page.